Good morning. We're going to work on approximating area under a curve using a right Riemann sum. And this example, we're going to consider just a straightforward linear function, the function 3x minus 4. And we're going to look at the area bounded from 2 to 5. So I thought I'd give us a picture here of what's going on. We've got this linear function, slope 3, and I've highlighted two of the ordered pairs that it crosses through. When x is 2, y would be 2, and so we have the ordered pair 2, 2 right here. And when x is 5, y would be 11, and I'll highlight that ordered pair, 5, 11. And so the right Riemann sum is going to approximate the area I've shaded here in red. This area would be a trapezoid. And later you might want to look back and think about what the area of this trapezoid would be. We have this area of a rectangle, width 3, height 2, and then we have the area of this leftover triangle with base 3, height 9, and of course the area of that triangle would be 1/2 base times height. Okay. But our focus today is finding the right Riemann sum, which approximates this area, and the area is bounded by the x-axis, the function we're given, the vertical line x equals a, and the vertical line x equals b, and we need to write down this expression with summation notation, k equals 1 to n, where k is the counter. We'll have the height of the rectangle, f, evaluated at x sub k, times the width of the rectangle. And we'll write this down again, but just to remind you, delta x, the width of a rectangle, we take the length of the interval b minus a, divide by n, and if we're doing a right Riemann sum, each x sub k, each grid point up here along the interval, is of the form a plus k times delta x, where a is the left-hand endpoint and k is just a counter, which we see up here in the summation notation. Okay. So yeah, we're going to do this specific problem for this specific function on this interval. Okay. But I wanted to review these again. Given any function on a closed interval a to b, we find the right Riemann sum for an arbitrary number of intervals n by using the expression delta x, which is created as this ratio b minus a over n, using the grid points x sub k, where each x sub k is a plus k times delta x. K changes, k is an integer because it's a counter or an index. And we're going to learn to write down an expression in summation notation, height of a rectangle times width. The grid points are the right endpoints of the interval, so that we create this right Riemann sum. Okay, let's get to that. Okay, getting a fresh sheet of paper here to work on. Okay, for this interval 2 to 5, we want to calculate delta x. And so that's the ratio, the length of the interval, which will be 3, divided into n subintervals. So each subinterval is length 3 sub n, 3 over n. Again, that's the length of a subinterval, because our overall interval had length 3, and we divided it into n equal parts. Well, this quantity delta x helps us write an expression for our grid points. These are demarcations of the endpoints of the interval, these subintervals. And we have to start within the interval, so we have to start at 2, but then we're going to add multiples k of delta x. So the 2 is a, which was given. We're using k as our counter because we're doing right-hand endpoints. And 3 over n was delta k. Okay. So since we were given a function, this linear function 3x minus 4, when we write down the heights of our rectangles, f of x sub k, that's going to be 3 times x sub k minus 4. And if we look back up here, x sub k was the sum 2 plus k times 3 over n. And I might write that just a little more compactly. 3 times k over n. Because we can think of k as k over 1. And now we have everything we need to write down summation notation for a right Riemann sum. Again, that's going to be f of x sub k times delta k, delta x. So we have the sum k equals 1 to n, and we look up here. We need 3 times the sum minus 4. Maybe put that in parentheses, because we're going to have to multiply that times delta x. And delta x is this fraction, 3 over n. And if a person's just asked to write down the right Riemann sum and not evaluate it, this would be the right Riemann sum for function f on the interval 2 to 5. Okay, so this is the end of part 1, and in part 2 we can use our summation formula to evaluate, but we'll let that be another video because that would be kind of long. Thank you.